Okay, this is Mr. Weideman, and I'm going to work one of the problems in your problem set on page 343. Basically, they are asking us to use the vertex and intercepts to sketch a graph and give the equations of the parabola's axis of symmetry. And then we're going to use the graph to determine the domain and range of the function. Okay, so on problem number 26, this is what I'm given. Now this problem is going to be fairly straightforward because my function is already given in standard notation. I rearranged it a little bit so I can easily pick out h and k, which are the x and y coordinates of my vertex. And I can say I got a negative sign up front, so I know from my parent function of a quadratic it's going to be shifted over to the right 3, up 1, and reflected over the x-axis, which is going to make it a frowny face pointed down. Okay, so if I have this information, okay, it's fairly easy to plot. I start with my vertex, and then I just do my transformation. I know I've got a reflection about the x-axis, so I can fill in those points, and there's my graph. Okay, my graph is split right in half by what we call this axis of symmetry. This axis of symmetry is the equation x equals 3. Where did I get that from? I got that from the x-coordinate of my vertex. Now at this point I can say, is this function even, odd, or neither? Now most of us attempt to say it's even because it's symmetrical. Yes, it is symmetrical, but not about the y-axis. It's symmetrical about a line x equal to 3, which is not the y-axis. So this is neither. This is neither. Okay, continuing on. Domain, simple enough for a quadratic. The x, it's continuous on all reals. The range, we have to be a little bit more careful. We see we have a top to the function. Top goes no higher than y equal 2. It will go up to and including 2, but no more. Okay, all that's left is these guys, x and y intercepts. The y-intercept is easy. The x-intercepts, sometimes not so easy. Fortunately, on this problem, they're fairly straightforward. All right, let's do the easy one. Let's do where we cross the y-axis. Well, I cross the y-axis at x equal 0. So all I have to do is substitute 0 into my function, and I get a y value of negative 7. So I intercept my y-axis at x equals 0, y equals negative 7. And we can go back to our graph, back up the video, and see, yeah, that's exactly where it is. Okay, now what about the x-intercepts? All right, now there's my function. Now when I intercept at the x-axis, the y is equal to 0. Notice how I put the 0 in for the y value. I went ahead and I FOILed together the x minus 3 term. That's where I got the x squared minus 6x plus 9. Now I'm going to distribute the negative sign and combine like terms. And when I do that, I get this function. I don't like that negative sign in front of it. So I can get rid of it. What I can do is I can multiply both sides of this equation by negative 1. Or I can distribute a negative 1 throughout both sides of the equation. Thank goodness I got a 0 there, so that doesn't change anything. All right, so now this thing is easily factored. So I've got two y-intercepts. I got 7, 0 and negative 1, 0, meaning if I plugged in 7 into the original function, I would get out a 0. That is where I would cross the x-axis. Also, if I plugged in a negative 1 into the equation, I would get another 0. It crosses the x-axis twice because it's a parabola. Okay, so that's what is required from this type of problem, where the problem is given in standard notation. and we'll try to work a problem where it's given in general notation.